In this video, we're going to look at how to average the zeros. And averaging the zeros is a method used to find the vertex of a parabola using the x-intercepts. So before we get to that, I want to look at a little visual. So I have a parabola here, and the x-intercepts are at -2 and +4, and the vertex is at 1, 4. Now, in averaging the zeros, we rely on our knowledge of the zeros, which are -2 and 4. Now we know that a parabola is all about symmetry, and that axis of symmetry is the line that cuts the parabola in half, and our axis of symmetry also passes through our vertex. So here the axis of symmetry is at x equals 1. Now x equals 1 has to be exactly halfway between -2 and 4 in order for there to be symmetry. So if I take my two values for the zeros, -2 and 4, and I add them and divide by 2, I'm going to get the middle or the halfway number. So -2 plus 4 is 2, and when we divide 2 by 2, we get 1. And that's exactly what our axis of symmetry is. So this idea of averaging the zeros starts from, if you take your zeros and you find the middle or add them up and divide by 2, you'll get the axis of symmetry. And the minute you have the x value of your vertex and you know what the equation is, you can sub this value in to get the y value. So right now I didn't set up an equation here for us to actually sub it in, but that's the idea of it. What I want you to take away from this visual is that the axis of symmetry, or the x-coordinate of the vertex, is halfway between your two zeros, which means we can average them to get that value. Okay, so let's get started. So to find the vertex of a parabola, one of the methods is averaging the zeros. There's another one that is called completing the square. Now, in order for you to average the zeros, you first need your equation to be in factored form. Because if it's in factored form, we can find our zeros, or your x-intercepts. Now, the x-coordinate of the vertex, so the notation we're going to use is x with a subscript of v for vertex, and that is the axis of symmetry. The x-coordinate of the vertex can be found by averaging the zeros, which means add them and divide by 2. Now, once you have the x-coordinate and you have that xv, we can find the y-coordinate of the vertex, and the y-coordinate represents the optimal value. And we can find this by sub in xv into your equation. And then when you simplify that, you'll get the y-coordinate, because that's what an equation is. It's a machine where you input your x and it spits out the y. All right, so let's try our first example. And in this first example, I gave you the equation in factored form already. And I want us to determine the zeros, the vertex, the y-intercept, and then sketch the parabola. So we're going to start off with our zeros. And for the zeros, you have to set y equal to 0. Because we know any x-intercept has a y-coordinate of 0. And that's just good for your communication. And now we have an equation and we can solve for the zeros. So here, I'll do it the long way for the first one. I'm setting x minus 2 equal to 0. So the x-coordinate is 2. That's 2, 0. And for the other one, it will be -4. So there we are. Our zeros are 2, 0 and -4, 0. Now, for the vertex, we're going to use this averaging technique. So for the x-coordinate of the vertex, I'm going to take 2 and -4, and I'm going to add them and divide by 2. So 2 plus -4 is -2, and when we divide -2 by 2, we get -1. So right now I know my vertex is -1 comma something. I just don't know what that something is. So I'm going to go to my equation and I'm going to replace x with -1. So I have 1/2 times -1 minus 2 and then -1 plus 4. So I'm just going to clean up each bracket. -1 minus 2 is -3. -1 plus 4 is 3. And now when we multiply 1/2 times -3 times +3, we get -9/2. And then we can fill that into our vertex. So our vertex is -1 comma -9/2. There we are. Now, for our y-intercept, you have two different methods that you can use here. You can either set your x equal to 0 and just simplify, or you can expand your factored form to turn it into standard form and look at that constant. It is more efficient to just replace x with 0. So that is what I'm going to do. So 0 minus 2 and 0 plus 4. And you end up with 1/2 times -2 times +4, which is -4. So that will be 0 comma -4 for our y-intercept. And now we can do a little sketch on the side. So my zeros were at +2 and -4. So it is very rough. But there it is, +2, -4. I know my vertex is at -1, -9/2. And if you want, you can turn -9/2 into a decimal just for an idea. And that is -4.5. So 1, 2, 3, 4. So it'll be halfway between -4 and 5. So right there. And then I can also plot my y-intercept at -4. And now I have quite a few points and I can connect my dots. And there's my parabola roughly sketched. And a good thing about a sketch is that if you've messed up on your numbers, it will be obvious because your parabola won't look proper, it won't look symmetrical. All right, on to the next one. So for the next one, it is in standard form. So we need to determine the zeros, vertex, and y-intercept. For the y-intercept, I can get that right away because it is in standard form and we know that the y-intercept is the constant. And because there is no constant, this is technically +0. So the y-intercept is 0, 0. Now, for the zeros, we need to factor this expression. And I'm going to start off by setting y equal to 0. So I have 0 equals -3x squared plus 12x. Now, the first factoring method we should always try and ask about is a common factor. And in this case, we do have a common factor of -3x. Remember, when the first term is negative, you want to factor out that negative number as well. And both terms have an x in common. So now you're left with x minus 4. And now we can branch off and solve. So be careful with that x that was a common factor. You want to set -3x equal to 0. And when you divide both sides by -3, you get x equals 0. So the first 0 is at the origin. And the next one, we set x minus 4 equal to 0 to get +4. And you don't have to show that step. I am just showing it in case you need it. So there we are. We have the y-intercept at the top, and now we have our zeros. And now we can average our zeros to get the vertex. So I'm using proper notation here, xv. I'm going to take 0 and 4, add them up, divide by 2. 0 plus 4 is 4, divided by 2 is 2. So now I have the x-coordinate of my vertex, and we can sub this into our equation. And it doesn't matter what equation you choose. You can sub it into the original standard form or into the one that you have factored. I'm just going to go into my original one. So -3 times 2 squared instead of x squared plus 12, and then instead of x I put a 2. And now follow BEDMAS, that's very important. So I'm going to do 2 squared first to get 4. Now I'll do my multiplication. Negative 3 times 4 is 12. 12 times 2 is 24. And now I add them up to get positive 12. So my vertex is 2, 12. And now we can do a logic check with a sketch to make sure it seems right. So I have a 0 at 0 and 1 at 4. So 0 and 4. The y-intercept is also at 0, which makes sense. Anytime a y-intercept is at an origin, the x-intercept has to be there as well. And then the vertex is at 2, 12. So I'm just going to say that's 12. And that seems about right. It has symmetry and my parabola is opening down, which makes sense because my a value was negative. All right, let's do the last one. For the last one, we should already know our y-intercept. And it is 0, 7 because it's the constant. For the zeros, I'm going to set my equation equal to 0. And now I'm going to factor. Now, there is no common factor here, so we're going to do decomposition. So you're going to need two numbers that have a product of 4 times 7, which is 28, and a sum of negative 16. And both my numbers should be negative, and it's going to be negative 2 and negative 14 for the magic numbers. And now we can decompose that negative 16x into negative 2x and negative 14x. And now we pair up. My first pair has a common factor of 2x, and then I'm left with 2x minus 1. And my second pair has a common factor of negative 7, and then again I'm left with 2x minus 1. So my factored expression is 2x minus 1 and 2x minus 7. Now I can branch off. And here you really do want to solve it properly and set each bracket equal to 0 and isolate for x. Because when we do that, we don't just get a whole number. So I bring the negative 1 over, it's positive 1. I divide both sides by 2, and x is a half. Or you can write it as 0.5. For the next one, I bring this negative 7 over, it's positive. I divide both sides by 2, and I get 7 over 2, which is 3.5. So my zeros are 0.5, 0 and 3.5, 0. And it's okay if you want to write it in its decimal form because this decimal terminates. If it were run on decimal, like for example for the fraction 1 over 3, I expect to see the fraction. All right, now that we have our zeros, let's finish this off and find the vertex. So I'm going to average them. 0.5 plus 3.5 is 4, and when I divide it by 2, I get 2. And now I'm going to go into my standard form that I started with and replace all of the x's with a 2, and now we clean up. I'm going to do my exponent first, so 2 squared is 4. Now I'm going to do my multiplication. 4 times 4 is 16. 16 times 2 is 32. And now we can add everything up. And we get negative 9. So the vertex is at 2, negative 9. And now a little sketch. One, 2, 3, 4, and we're at 0.5 and at 3.5, and the vertex is at 2, negative 9. Let's say negative 9 is here. And our y-intercept is at 7. Let's say 7 is there. And again, it's just a sketch. That's why it looks quite rough, but it seems good. Nothing is wonky. If you had done your sketch and your vertex was way over here, but your zeros were here, you would know that you messed up somewhere, probably with the signs. All right. So on a separate piece of paper or somewhere on your notes, I want you to try this last example here. I just wrote it in. I want you to try it on your own. So find your y-intercept, factor it to get your zeros, and then average to get your vertex. So pause the video, try it, and then I'll take it up. All right, so for your y-intercept, hopefully you wrote -30 because of the constant and the fact that it's in standard form. If you factor, hopefully you found the common factor and then did a simple trinomial. If you did decomposition, you should still end up with the same zeros. It's a longer process. So we should have -5 and +3 for the zeros, which when we average them, we get -1 for the x-coordinate of the vertex. Now, when you sub this value in, if you subbed it into the standard form, please make sure that when you take -1 and you raise it to the power of 2, it is a positive number because a negative times a negative is positive. And then from there, when you simplify everything, hopefully you got -1, -32 for your vertex. So see if you did that well. If you made a mistake, check to see where you went wrong so that you don't make that mistake in the future.